Hello my dear students, in today's video lecture we are going to see conversion of flip-flops. As per a previous video we are concerned with the different working operation of different flip-flops like SR, JK, D and T flip-flops. Okay, and today's video we are going to see how one flip-flop is converted into another flip-flop. If suppose we are know about the NAND and NOR as a universal gate. If any gate is not present in us, then we can implement that gate with the help of NAND and NOR. In similar way, if SR is available and we want to implement JK, but JK is available if want to implement SR, then at that condition we have to know about the procedure how to convert one flip-flop into another flip-flop. That's why there are certain rules. The rule is first, draw the characteristic table of flip-flop which are going to be implemented. For example, in this example we are going to implement JK flip-flop by using SR. So by considering first step, we have to write a characteristic table of the JK flip-flop. Then write the excitation table of the resource flip-flop. In this, the resource flip-flop is SR, which flip-flop is available in our hand, that is resource flip-flop, that is SR flip-flop. And then write the conversion table of the JK and SR flip-flop. These are the three steps which we have to follow for the implementation of JK by using SR flip-flops. Okay. Then which way, what is meaning of characteristics table? This is a characteristic table of the SR flip-flop. Okay, in which we'll study in the operation of SR flip-flop 0 0 0 0 0 0. If present state is 1, then x of q of n plus n is also 1. 0 1, at that time the flip-flop is reset, so q of n plus 1 is also 0. When set is 1 and r is 0, at that time q of n plus 1 is 1. Such kind of flip-flop is called as set condition of flip-flop, and both are 1 1. At that time we cannot predict the q of n plus 1, so it is called as race around condition or invalid condition of the SR flip-flops. Okay, this is a characteristic table of the SR flip-flop. This is a characteristic table of the JK flip-flop. We study each and every characteristic table at the time of working principle or working operation of each and every flip-flops. Okay, this is the excitation table, which is little bit different as compared to a characteristic table. Okay, let's go with the excitation table for the SR flip-flop. This is a 0 0. Okay, for the implementation of this first step, we have to know that characteristic table of the SR flip-flop. At this condition 0 0, okay, we have to analyze what is the input bits of S and R. Okay, here S is 0 and for this condition S is also 0. So the bit of set or S is not going to be changed, so we write here 0. Okay, then analyze second input. This R is 0 but here R is 1, so the reset input or R input of the SR flip-flop is going to be changed. So if the bits are going to be changed, then we have to write X. Okay, then next for the 0 1 condition, let's study 0 1 condition. Q is 0 and q of n plus is 1, so 0 1. At that time what is the input condition? 1 0. This state is not repeated anywhere, it is only available once. Okay, so for this set is 1 and the set is 0, this condition. Okay, the next 0 1 0 1, this condition is a 1 0. The 1 0 condition is available here. Okay, if you observe carefully, this available is once in the entire characteristic table, so we can write 0 1. So this is a 0 1, and then last one is 1 1, which is available here. Okay, and which is available here also. So At that time we have to analyze the input bits. What is the input bit? 0. We'll observe first yes, okay, and for this yes is 1, so yes bit is going to be change. First is 0 and for the second condition it is also 1, so this bit is going to be changed, that's why we write here x. And next we'll study another input, that is reset. This is r is also 0 and r is also 0, so the r input bit is not going to be changed, its value is 0, so we write here 0. I hope so you understand the excitation table of the SR flip-flop. Okay, in the similar way we can find out the excitation table of the JK flip-flop. First, what is the input conditions? Q of n and Q of n0 are 0 0, which is available first here, okay, and which is repeated in the entire time characteristic table. Yes, this is repeated here, okay. For that, observe input bits. J is 0, J is 0 also, so there is no bit change of the J, so J is becomes 0, okay. For the K input, this K is 0 here and this is 1, so the bit is going to be changed here. So if the bits are going to be changed, then we write here X, okay. In the similar way, what is the second condition? 0 1. For the 0 1, this is the input, okay. For this state is not repeated anywhere, this state is not repeated anywhere, so what are the inputs? J is equal to 1 and K is equal to 0, J is equal to 1 and K is equal to 0. For this, J is equal to 1 and K is equal to 0 1, okay, sorry, this is repeated once here also. So what is the J bit is 1 and it is here is also 1, so we'll write here 1, okay. We'll study what about the K bit. The K bit value is 0 here, but the K bit value is 1 here, so the K bit is going to be changed. So if the bits are going to be changed, then we write here X. Then last 1 0 condition, which is available here, okay, and this is also available here. For that, study the input bits. Here we will first assume J bit. What is the value of J bit? Is here 0, and what is the value of J bit is here 1, so J bit is going to be vary, so we will write here X, okay. Then next, what is the value of K bit? Is 1, and what is the value of K bit is also 1, so K bit is not going to be changed, so we write here 1, okay. Then last 1 1, this is the one state, okay, and this is another state. So we'll assume we'll study the input bits. This is J is 0 and here J is 1, so this bit is going to be change of the J, so we have to write X here, okay. Then study K bit. K bit is 0 here and K bit is also 0 here, so we write only 0. I hope so you understand the excitation table of the JK flip-flop. In the similar way, in the similar fashion, we have to write the excitation table for the T flip-flop as well as D flip-flops. I hope so you write the excitation table with the help of characteristics of these remaining flip-flops in as a home assignment, okay. Then take one example. The example is that, what are the example? Realize JK flip-flop by using SR flip-flop, okay. Then what are the steps? Again, understand the questions. We want to implement JK flip-flop, and what is the resource flip-flop is SR. So write the first characteristic table of the JK flip-flop. So 0 0 0 0 0 0 1 1, these are the characteristic table which are studied in the working operation of the JK flip-flop, okay. I am not going to explain here once again. This is a no change condition, this is called as a reset condition, this is called as a set condition, and this is called as a toggling condition of the JK flip-flops. Okay, then excitation table, which is see right now, when 0 0 we have to know that 0x 0 1 1 0 1 0 0 1, and for 1 1 it is x0. Be carefully, we complete first step by as per rule we write the characteristic table of the JK flip-flop. The second step, write the excitation table of the SR flip-flop, that is the resource flip-flop or flip-flop which are available towards us. Okay, after the completing of these two steps, then we have to follow the third step, write the conversion table of the JK flip-flop as well as SR flip-flops. I hope so you understand these two steps. For that you have to know about what is the characteristics table, what is the excitation table. Okay, then go through with the third step, write the conversion table of the flip-flops. Okay, so this is a conversion table of JK and SR. We only consider first write characteristics table of the JK flip-flop, which is right here. Okay, then just copy the characteristic table of the JK flip-flop in this step. Then we study the Q of n and Q of n plus 1. Okay, both are 0 0. If both are 0 0, then what is the S and R? This is a 0 and this is a X. Okay, then both are 1 1. If both are 1 1, then X is 0 and R is X is S is X and R is 0. Then both are 0 0, again 0 X. Okay, then next 1 0, for 1 0 S is 0 and R is 1, S is 0 and R is 1. Then 0 1, S is 1 and R is 0, for 1 1 X 0, for 0 1 1 0, and for 1 0 0 1. Okay, these are the values of set and resets. Once we are able to find out the values of set and resets, right now draw the K-map. Okay, the K-map is nothing but inputs J, K and Qn. We are not going to consider Q of n plus 1 as an input. So we are only considering these are the inputs which are J, K and Qn. So we need 3 variable K-map with the inputs are J, K and Qn. Okay, these are decimal values 0, 1, 2, 3, 4, 5, 6 and 7. So write down the values of respect to their. Okay, then this is for the set, this is 0 for 0. Okay, this is a X for 1, again this is a 0 0 for 2 and 3. Okay, then this is 1 for 4, then again it is X for 5, then it is 1 for 6, and this is 0 for 7. I hope so you understand the K-map for the set. Okay, in the similar way we can find out the K-map for the reset. X is present as 0, so right here don't care condition. Okay, 0 at 1, X are again at condition of place of 2, at 3 we write 1. Okay, and 4 5 6 we write 0, 4 5 6, at decimal value 7 we write 1. Okay, so with the help of this K-map we have to find out the grouping. So grouping can be available here. First grouping, which is corner grouping, from these two columns, this one and this one, what is the common value? 0 is common, so we can take Qn complement. Okay, from this entire row the J is only common term, so J is the common one, so set is equal to J into Qn bar. Okay, then what about reset. Okay, we have to use this as an grouping element. So here both values are k into q of n, k into q of n. In this way we have to find out the logic value or logic diagram of this. So which flip-flop is available? Set and reset. So first draw logic symbol of set and reset. Okay, outputs are q of n and q of n bar. We are using here positive edge triggered flip-flops. So for the yes we need j into qn bar. So we'll use the relation which is defined by the AND gate. So we will use here AND gate. Okay, and another input to the AND gate is from the qn complement. Okay, in the similar way for the reset input we need k into qn bar. So take one more input, that is k, and the input to this another is k. So this flip-flop is works similar with the JK flip-flop. I hope so you understand the first example in which we are going to realize JK flip-flop with the help of SR flip-flop. Okay, in the upcoming video we'll see one more example which are based on conversion of one flip-flop to another flip-flop. Let's consider second example in which we are going to implement a JK flip-flop from D flip-flop. Okay, so read carefully the given statement. In this statement we have to implement JK flip-flop and the resource flip-flop is a T flip-flop. So we have to follow the guidelines which are useful for the conversion of flip-flop. So first rule is that draw the characteristic table of flip-flop which are going to be implemented. Okay, this is first rule. Second rule, write the excitation table of resource flip-flop, and the third one, write the conversion table of the JK and SR flip-flops. These are the three important guidelines which are useful for the implementation of any flip-flop from the resource one. So first we have to draw the characteristic table of the flip-flop which is going to be implemented. Here JK flip-flop we want to implement, so we have to write the characteristic table of the JK flip-flops. This is the characteristic table. I think you are easily familiar with this characteristic table. Then this is a excitation table. I hope so. In this lecture, video lecture, we are design how to draw a excitation table with the help of characteristic tables. So in that we take two examples which is for the SR flip-flop as well as JK flip-flop, and now we only just draw excitation table of the D flip-flop in which 0 0 is the 0, 0 1 D is the 1, 1 0 D is the 0, and 1 1 D is the 1. These are the conditions for the excitation tables. Then next third rule is that we have to write conversion table. For the conversion table, J and K are the inputs, Qin is the present state, Qn plus 1 and D. Okay, for that we just write here first a characteristic table of the JK flip-flop as it is, and we have to write a D inputs, so that for the D when both are 0 0 we have to use 0, when both are 1 1 the D value is 1, when both are 0 again D is a 0, for 1 0 D is the 0, for 0 1 D is the 1, for 1 1 D is 1, for 0 1 D is 1, and for 1 0 D is the 0. This is the conversion table. This D value comes, or we can find out with the help of excitation table inputs. For example, if both are 0 0, then we have to look into excitation table. When both are 0 0, present state and next state, what is the D? It will be 0. Then next 1 1, for 1 1 combination of present state and next state, what is the value of D? Is 1. Okay, in this way we find out the values of D. Then draw the K map, which is for the D. So with the inputs J, K and Qn, these are only input part which we have to consider for the implementation of K map. So when D is 1, for the decimal value 1, for decimal value 4, for decimal value 5, for decimal value 6. For these inputs, for these combinations, the D value are 1 and remaining all are, it will be 0. So it's time to find a grouping. This is the first grouping. Okay, this is the second grouping. Then just write down the common terms for this. From this, J is the common because this is a common term, common for the row, and from this we can getting Qn complement. Okay, and from this we are getting K bar into Qn. So D is equal to J into Qn bar plus K bar into Qn. Okay, with the help of this logic expressions, we have to draw a logic diagram or circuit diagram for the JK flip-flop with the help of D. So we know that the inputs we are going to use D flip-flop. So take first D flip-flop as it is. Okay, there are two outputs Qn and Qn bar. Then next, for the D input, we concern with the first term. What is the first term? J into Qn bar. So take input J. Okay, the another input is Qn bar, which is comes from this point. Okay, then next, this is J. Let's concentrate on the second term, which is K bar into Qn. So take one more input K. For this gate, for this term we have to use AND gate, and this also we have to use AND gate. So for this, another input is comes from Qn. Okay, and then this term and this term are added together, so we are going to use OR gate. Okay, in this way this D flip-flop can be acts as an JK flip-flop. This is a process in which we can implement any kind of flip-flop with the help of another flip-flop. This idea is similar like a implementation of any basic gates, derived gates with the help of the universal NAND gate as well as NOR gate. I hope so you easily understand the concept of conversion of flip-flop. Thank you very much.